We're just going to skip through just a quick introduction to when we're talking about life in the soil, what does that mean? And I'm hoping by the end of this session, you're going to go, oh, look at that the soil is more alive than I even could imagine, which is what I did, which is why I keep going deeper and deeper. When I looked at the microscope for the first time, it felt like I had been given glasses, and I could speaking of glasses, and I could finally see. And so I hope you feel the same way about that. Basically, when we're talking about the Earth, it's not a platform for human life, it's a living being, and we're not on it, but we are part of it. And I think that you'll get to learn more about that as we go. I don't know if you know Vandana Shiva. She comes to where we are in Connecticut quite often, and her wonderful expression, in nature's economy, the currency is not money, it is life. And that we feel very strongly about.
That's profound. Yeah.
Is that profound?
Yeah.
So this is you talking about what's going on.
Yes, so let's, can we run the video?
Yeah. Do you want to do a little intro first?
Yeah, so for us, and not for many, unfortunately, and that's why we produced it, it was becoming quite evident that modern day food and modern day medicine are making us sicker and not healthier, right? But not many people know about that and why that was happening. So we were compelled to raise money and produce this website, which is called www.modernepidemic.org. You can Google it up, and this is on it. And I wanted to at least show a couple of short video animations on the human microbiome and how our human microbiome has been perturbed, similar to the way agricultural soil has been perturbed. And that's why I thought it was appropriate to bring it up, because they are inextricably linked, in terms of soil health and human health.
During the Industrial Revolution in the mid-1800s, millions of people moved into the cities. People lived packed in crowded rooms, without clean drinking water or fresh food, and open sewage ran in the streets. Due to the resulting poor living conditions, 1 in every 4 children died before they turned 1. In the early 1900s, improving socioeconomic conditions and the implementation of public health measures such as safe food practices, sewage systems, water treatment systems, and basic hygiene made a tremendous impact. Less than 2 in 1,000 children now die before the age of 1. Unfortunately, while the public health measures reduced infectious diseases, we aren't healthier. In fact, infectious diseases have been replaced with skyrocketing chronic conditions such as diabetes, obesity, asthma, allergies, Crohn's, acid reflux, cancer, Parkinson's, Alzheimer's, autoimmune diseases, and other chronic and inflammatory conditions. 1 in every 6 American school children has a neurodevelopmental delay or disability, and our infant mortality rate ranks last in a recent study of 34 developed nations, despite the fact the U.S. spends more on healthcare than any other country. Other Western and developing countries are also witnessing record rates of these chronic conditions. This all relates to what we call the human microbiome, and this microbiome is in jeopardy. To understand this better, let's look at the definition of a biome. A biome is a naturally occurring community of flora and fauna occupying a particular habitat. The human microbiome is trillions of bacteria, fungi, viruses, and other organisms that live in our mouth, our gut, nasal passages, ear canal, and all over our body. These microbes have been in and on our bodies since the beginning of time, passing down from generation to generation. When we leave the birth canal in a natural birth, we are immediately immersed into a vast sea of trillions of microbes from our mothers that begins to train our immune system and define who we are. The first opportunity to ingest food is when the mother secretes colostrum, pre-milk, which gives the baby nutrients. These unique nutrients feed specific microbes, which are coded to perform functions central to the breakdown of sugars and building our immune system. And every contact the baby has with people and its environment helps increase its exposure to microbes, which again helps train the immune system. All this seems wonderful, but then why are we getting sicker as a society? What we know is that when we sterilize our environments at birth with antibiotics and later as adults with hand sanitizers and obsessive hygiene, We kill these helpful bacteria that we host. We destroy our microbiome, our microbes. And today, about 30% of mothers get C-sections in the US, and more than 50% in other countries. What this means is that in this case, the baby does not travel through the birth canal and get seeded with the microbes that help fight off disease. And this often means that antibiotics and other drugs are used in this process, which kill off helpful microbes. Research shows that missing microbes from cesarean births, as well as overuse of antibiotics in medicine and food, processed foods, and pollutants in our environment, are impacting our internal ecosystem in ways we are just beginning to understand. And these missing microbes have implications for the modern plagues that are surfacing today.
I think the take-home message here is that our human microbiome has been profoundly perturbed by modern medicine and modern food. And so that our ecosystem, our inner ecosystem, has been completely thrown out of balance. And likewise, agriculture has changed. I mean, we're just not growing food as we know it today, organically, using compost and no-till and regenerative style methods, but instead the vast majority of food that Americans and other people in other countries can consume is grown conventionally, where pesticides, chemicals, and synthetic fertilizers are used. Till is the primary, not no-till, method of cultivation. And as a result, let's just call it the microbiome of the soil, which we can think of as a very large living organism, has been perturbed like the human microbiome. Well, the thing is for hundreds, if not thousands of years, humans have been very closely linked to the production of food until it became commercialized. So we've lost connection with the soil. We're not touching it anymore and interacting with it anymore. And as a result, our human biome has been affected by that. And I think that's really the underlying point here, which is what the next video will show.
Antibiotic resistance is a serious threat to our existence as a species. To understand it properly requires a brief history of how we began. Over 100,000 years ago, our hunter-gatherer ancestors lived their lives foraging for food, collecting wild plants and hunting wild animals for survival. If you have heard the phrase, "you are what you eat," this applies to the food we have eaten for thousands of years. We evolved from these foragers who sourced their food in the wild, and our microbes today, long before modern medicine and industry made their impact, were influenced by our ancestors and the microbes in their bodies, partly from food and water they ingested. Over time, a more civilized society brought with it agricultural communities where people became dependent on domestic animals and cultivated crops. Our microbes continued to be influenced by our environment, which during this time was free of chemicals, herbicides, pesticides, and antibiotics. Fast forward to more modern times, and we started to see major changes with big cities and dense populations. And with more people, farms grew larger with more livestock. And with more people, for various reasons, we started to see more illness. One of the major discoveries during the Industrial Revolution was the introduction of penicillin in 1928, which killed bacteria that caused disease. This was the first modern-day antibiotic, and it saved the lives of millions. And this is where our microbes also started to see major change. Two things happened. First, the medical community began to use antibiotics generously for common childhood issues like ear infections. And so children started to get frequent doses of antibiotics, when in some cases it was not critical to do so. And big business saw opportunities to use antibiotics in a different way. They learned that they could produce food faster using antibiotics for weight gain, which was especially helpful when selling animal products by the pound. They also added in herbicides, pesticides, and synthetic fertilizers in the soil, as a result, changing the microbiota of soils in the food that we eat. Today, we are continuously ingesting these antibiotics and other toxins which accumulate in our food, water, and soil. Over a period of time, these low doses of antibiotics helps us develop what we call antibiotic resistance. Here is an example in how it works. Animals get fed low doses of antibiotics daily, And over time, they develop antibiotic-resistant bacteria in their gut microbiome. And then we eat the animal products carrying this drug-resistant bacteria. Fertilizer or water that contains animal feces with drug-resistant bacteria and other toxins is also used on food crops, where fruits and vegetables are grown and then eaten by humans. And so, when you have a plate of steak and carrots, you might be getting a dose of drug-resistant bacteria in your body and not even be aware of this transfer. What happens when we have an abundance of antibiotic-resistant bacteria in our gut? We get sick, and there are no medical alternatives to antibiotics available to cure us. And what happens when these antibiotic-resistant bacteria reach large numbers of people? This misuse and overuse of antibiotics, the chemical-dependent production of food, and failing stewardship of the soils alters the chemical and biological makeup of our food, which in turn alters the chemical and biological makeup of our microbiome. In many cases, due to the lack of transparency of food suppliers, we are unaware of what we are really putting into our bodies. We must, as a community, demand that big business stop adding antibiotics, herbicides, and other toxins to the soil and food supply. We must, as a community, support local and regional farmers who practice healthy farming. We must, as a community, carefully consider our choices each time we are prescribed antibiotics to determine whether or not the treatment is necessary, and learn about the potential side effects of this treatment. And we must, as a community, spread the word, because it starts with us, and together, we can make a difference.
There's a big misunderstanding out there that organic agriculture is all about not using pesticides and not using synthetic fertilizers and sticking to that USDA definition, whereas in reality, we take it much further, and what we're trying to make people understand is that it's really about what you don't see, okay? It's what's below the soil and in the soil that has always made a difference in long-term human health. And because of commercial agriculture and because of modern-day organic agriculture, quite frankly, we have lost that connection. And I firmly believe that if more people had, gardens, and more people ate from local organic farms, and more people got their hands dirty and ate more locally and regionally, the transient microbes that are out there would make it into them and become a part of their microbiome, and they would be a lot healthier for it.
So just some of the stats here. Soil and the human gut contain approximately the same number of active microorganisms, while the human gut microbiome diversity is only 10% of soil biodiversity, which I didn't realize. So
maybe at one point it was a lot more than that.
Maybe.
Yeah.
We don't know.
Yeah.
The other interesting thing, there's a close linkage between the soil microbiome and the human intestinal microbiome that's evolved through evolution. With soil health, when we're talking about that, it's really the continued capacity of the soil to function as a living, vital ecosystem. And so what does that look like? Well, we all know the difference. This is an NRDC poster that I found talking about the difference between dead soil and living soil. So no microbes at all versus living soil that has a vital living micropopulation. So bare soil first is unprotected. It's going to have erosion because of that. You're going to have to use increased chemicals because there's no other source of food for them. And of course, there's going to be pests that you have to deal with. While if you're looking at living soil, number one, if you have earthworms, generally it means that they are at the higher trophic level. And so that's a good sign that you have other things going on below at lower levels. You're going to have residue from past plants, so you don't want to remove things from the garden. You want to let things settle. Do not disturb is sort of the number one thing. The microorganisms will stabilize the soil, and we'll talk about what that symbiotic relationship is between the plant and the microbes.
So that's a good point. Just to pause real quick. So the disturbance of a living soil like that, which is what Monique is talking about, an example of that would be tilling. Okay, so in modern day organic agriculture, tilling is completely acceptable, and it's okay. I'm not saying that it isn't. It's a method of agriculture, both organically and conventionally, but it does mess up that home,
that community of
that community. Yeah.
So we'll see what that looks like when you do that. Let's talk about how you can build up the soil and sequester carbon. And of course, the number one, do not use chemicals. So one application of chemical fertilizer, according to Zach Bush, will kill half the life in the soil. And he also says tilling can be just as dangerous and harmful to the microbes. So any type of chemical you really don't want to put in there. Plant diversity. So just like if you grow a monocrop, you're going to have certain microbes that go along with that. The more diverse your plants are, the more diverse the life will be in the soil. You must know Craig Floyd from Giving Garden. I remember him doing a presentation once and he goes, "Mother Nature wants to be covered." And I remember that so perfectly. And that is, you don't want to have bare soil under any circumstance. The best way is to have as much growing through the year as possible. Using perennials as much as you can, ground covers, so that as much of the soil is covered as possible. And as I mentioned, the intercropping between whatever is growing, that there's always new plants being put in there and will add to the diversity. So anytime you see soil bare, number one, it's going to be bacterial dominant, which we'll talk about what that is. And it really is releasing carbon, its life and its vitality. So microbiologists, here we were talking about 1.5 million species of soil fungi and 3 million species of bacteria. That's what they're estimating.
Those are individual, those are species. Which is amazing. So when you look at the actual number of
Right.
bacteria in a handful, it's just like a multiple of that.
Yeah.
Big
Exactly.
multiple of it, yeah.
And if you look at agricultural soils, usually there's about 5,000 species, which is a huge difference. Something else, and this is when I kind of do my silliness, 50% of the energy a plant takes in, up to that, it will put through the roots to feed the microbes. So again, here I am, a plant, I'm doing the photosynthesis, I'm taking in all this energy, and as 50, sometimes up to 70%, I will feed through the roots to feed the microbes.
Hence the reason why you want to have your soil covered for so long.
Right. And the
As much as possible.
Bionutrient Food Association explains that again. So these are called sugars, or as my teacher, Dr. Elaine Ingham, called them cakes and cookies, that get put through the roots to these beneficial microorganisms, bacteria, fungi. And in exchange, these microbes will take in that sugar as food and be able to give back to the plant any nutrients that plant has the potential to take in. So it's that symbiotic relationship, and we want to keep that going for as long as possible. And this is a wonderful cross-section of some of the life that is in there doing these things. So these minerals are digested and then fed back to the plant, and this is the core of soil fertility, what we're talking about, this symbiotic relationship. And this is actually available online. This is from my teacher. If you just type in Adding Biology by Dr. Elaine Ingham, it's a PDF that's free online, and it explains this. And of course, she has cakes and cookies so that you will remember. She's a great teacher. Soil Food Web is the work that she does. And this is the Soil Food Web. Gabe Brown, who's doing amazing work in the Midwest, teaching farmers there about the importance of this, says the soil beneath us is alive. There are more microbes in a teaspoon of healthy soil than there are people on Earth. So that's a staggering statistic. And just to see what this looks like, the smallest, or the first and second trophic levels is really the bacteria and fungi that we're looking at. And then they have predators. Everything from the smallest flagellate in the protozoa family to the more amoebas and the ciliates, and then we have the nematodes, and then the arthropods, microarthropods, and it moves up from that. So there's something else interesting in that there's always some balance between, I talked about bacteria and fungi being like the second trophic level, and they are really the engines behind this. And so the minute you disturb the soil, it's going to be bacterial dominant. And so then it's Mother Nature's way, right? You're selecting for weeds, which is not what we want to grow. If you go into an old growth forest, it's going to be 100% fungal. What we want to grow is in the middle here. So we want to have a balance of bacteria and fungi. So what does that look like? So if you're growing something like brassicas, they can handle more bacteria. But as you're moving towards a woodland edge, when you're talking about perennials and now strawberries and things like that, you'll want to have more fungal in your soil. And what does that look like? Well, these are what bacteria look like. This is 400 times magnification. This is fungal. And so we're going to be looking at these when we look under the microscope. There's some more fungal hyphae there. And I would describe it as a beautiful piece of fungal hyphae. This is one of the smallest predators. This is a flagellate. These are fungal hyphae in here. This is a nematode. Different types of nematode. Generally, I see a lot of bacterial feeding nematodes, but that's a sign that you have a greater diversity of soil microbes in your soil. This is zoomed in. You can see he's full of bacteria. And these here are aggregates. And bacteria is sticky, and they are actually bacteria. So you get amazing soil structure when you have a lot of bacteria. They'll form these aggregates, and now it'll be moisture retention and nutrient retention right around the roots of your plant. This is a microarthropod. I'm always amazed at how much detail there is. Now we're zoomed in about 200 times. Look at the detail on this microorganism that we would no way be able to see, and yet he almost looks prehistoric. Here's another guy. So again, these are the aggregates. There's a little piece of fungal hyphae there, just so when you do look at the microscope of some of the soils here, we'll be able to identify what they look like. And this is a ciliate, and it's a cilia or hairs. And generally, if you have like a stinky pile of compost or soil that's been waterlogged, it will tend to become anaerobic. And then you'll get these anaerobic loving, they're amoeba, but they are not what you want to see, and they will start taking over. So that's a good reason to not have sopping
Anaerobic
wet
conditions, yeah.
compost or soil that's
And
oversaturated.
that's probably why raised beds are a good idea.
Yeah,
for instance.
if you do have soil that tends to get waterlogged. Here's a sample that somebody sent in and said, wow, I've got some great compost tea, take a look. And this was when we were visiting Dr. Ingham, and those are all ciliates taking over. And they've eaten all the bacteria, and guess what? You now put that tea on your garden, you're going to have them eat all the bacteria in your garden. So also a really good reason, if you are doing this and you're concerned about the microbes, that you look and identify what is in there. So especially when you start making compost tea, hoping to have beneficial microbes on your plants and a foliar spray and around the roots, you want to be able to see with a microscope that it's viable and it's the beneficial microbes that you're multiplying. This is another, I love this kaleidoscopic guy. He's full of bacteria, but he's just pretty amazing, 400 times zoomed in there. And here's another, this is an insect larvae. So if you have a compost pile and you have a lot of fruit flies, they're going to lay these eggs, and then you'll have these larvae. Also a sign that it's anaerobic. But you can see he's taking off chunks of this aggregate that's full of bacteria. This is a potworm. Look at the difference between these nematodes.
So this is a good example, Moody. So this
potworm.
is an example of, as we learn more and more about what this ecosystem and all these organisms that are in the soil interacting with each other. Whereas humans, we can actually, just like we can at Yellowstone National Park, if we have this knowledge, then we can actually manage better.
Exactly.
Right?
Yep. Knowing what is going on down there. So let's see if you can find, I know that there's a nematode here. See if you can find any more. This is some worm castings. We had a worm co-op in Rhode Island that was started by Nancy Warner. So we all came together and we would look at each other's samples. This is amazing, the amount of microarthropods and nematodes in this one field of worm castings. This is just a quick example. When you take chemical soil and organic soil and just add a little worm castings. Look at the difference in the amount of germination and the size already. And then we look a few weeks later, look at the color difference. This was sort of chewy, and this one was crunchy and sweet. So you could taste the nutrient difference in the food. And then this is 10 days or 20 days later. And look at, this is now disease-ridden, crap, it really looks bad. And this one just took over. So again, exactly the same number of seeds in the same pot, same conditions. The only difference was the soil.
Nice.
What does that look like under the microscope? So this is the bag soil with the chemical fertilizer. There's no aggregates. So what I find is there's bacteria, but they just tend to shiver in space. They don't interact. Where if you compare that to, this is the side with the organic soil, see the aggregate formation? There's a nematode, there's pieces of fungal in here. It's alive. And that's what's going on. When you see that below ground, that's what's going on and the effect that it has above ground. We're just to recap here. We want to have that thriving diverse plant community and compost.
Our system of production is in the greenhouses is raised beds. So we do what we call a no-till, which is basically just taking a pitchfork and not turning the soil, but just loosening the soil. And we add, before we do that, we add compost and natural organic mine materials. And there's just loosen the soil with a pitchfork and then shape the bed a little bit with a hoe. We're religiously adding compost. So we make all of our own compost here from crop residues, from our animal bedding and some stuff that we bring in, food scraps from student contributions, restaurant contributions, and we compost it 3 to 6 months depending on what we're bringing in and what time of year it is. But that's our main fertility. So that's what we rely on is compost.
I think we're going to start heading out and getting some samples and looking at the microscope.
Okay. So this pile was very large in the spring. Pretty much came all the way up to the top of the wall. This is just what's left of it. So this is our oldest compost pile. And we're pretty much have depleted it. But I grabbed a little bit here off to the side. And you can see that it's pretty fine, I mean, it's like dirt, more or less. So we'll name this compost pile number 1, which is the oldest. And somebody asked how old this was. So this probably 6 to 9 months old now.
So this is compost from the first pile, the oldest, most mature pile. There's a piece of organic matter there. We're zoomed in 400 times magnification. You do have a good diversity of bacteria. So you can see we have a lot of these are rods, and then we have cocci, different colors, different sizes. So that's good to see that. We would like to see more of these aggregates. So from when I saw that pile, I assumed that this is sort of what we would get because it does look somewhat dried out, which would tend to cause...
Some more aggregate there though,
yeah,
right?
yeah, but
I'd like to have more.
You would like to have more.
Yeah.
So when we go back to 100 times magnification, you can see it's similar throughout, but I do like that we have quite a lot of fungal hyphae in here. So now that this plant matter and food waste and things have been broken down, it's created soil again. And now we can start that relationship with the plants. Now that looks like an amoeba there. See that semicircular thing in the center there? Yeah.
Right there.
But I think for the age of this and what it looked like, I think it's looking much better than I had anticipated, which is great.
Good.
So that's sample 1. All right, so this is from the Coast of Maine bag, which is compost, organic and natural, with lobster and crab. And what we're finding here is at 100 times magnification, there seems to be a lot of fungal and some organic matter, but you see how empty the space is here. If I go to 400 times magnification, you just don't have the bacterial numbers. Great diversity of fungal though, which is nice to see, but also not the aggregate structure, mainly because there's no bacteria to stick together.
Right.
So it was probably made from a high carbon source.
Right. So this is a little more dead per se.
I would say.
Yeah.
And you can see there's not a lot going on. But imagine if you mix this with all this really cool fungi in here with a high bacterial count in another type of compost, like the one we just looked at.
Yeah.
You would be able to, it would go a long way, let's just say. So it's
a lot to be said for mixing.
Yeah, and knowing what you have, and again, diversity,
Yeah,
right?
yeah.
Taking different types of composts and combining them.
So you have another test tube for me?
When did you start this one?
This one was started, I would say, in the spring. Yeah.
That's plenty.
Yeah. So we're going to call this number 2.
This is 200 times magnification. We're seeing this flagellate who's doing his
There
own,
he is. Look.
yeah,
He's.
his own tricks in there.
What is that? What do we define? What's a flagellate?
A flagellate is one of the smallest predators. It consumes bacteria.
It consumes the good guys.
Right, in a good way though. See how it's not crazy consuming everything in sight?
Right.
So it's good
keeps things
for
in check.
nutrient cycling. Yeah, and it means you have a diverse soil food web. You don't just have bacteria and fungi, you have
You got
larger
predators
as well.
and prey.
So something like this could be used almost immediately.
Yes, this actually looks really good. How old was this compost?
Probably like 3 to
Spring.
3 to 5 months, maybe
Right.
6.
Okay. So
Whereas the other ones was more like 6 to 9, I would say.
Right.
Closer to 9.
So you have aggregates in here.
That there is a.
That's that looks like organic matter that has aggregation. So there are
Oh yeah.
microbes
Yeah,
that
the
are
lighter
sticking
stuff
to
in
it.
there. Yeah, yeah. Fascinating.
right. See that aggregate there, full of bacteria.
This is so much different than that commercial stuff.
Yeah, it's so different and diverse, right? Every field is different.
Yeah.
So that's
he's
an
a
amoeba.
he's a predator.
Yeah,
Pac-Man.
he does look like Pac-Man. Oh boy.
Everything is in.
He's having a field day in there,
Cool.
bouncing around.
Right? Anyway, look at all of these really nice septa or separation between the segments of this fungal hyphae here. We're 400 times. There's a testate amoeba. We saw some predators, flagellates, bouncing around. Organic matter, another piece of fungal hyphae there. So this is really, really full. Through a combination of collaborative initiatives and exciting new research, organizations like the Ayers Foundation, NOFA, and Wiggle Room are uncovering important details concerning what microbes contribute to optimal soil health, which consequently impact human health. It is no longer enough to simply grow and eat organic foods. We need to go deeper, literally, into the soil to heal and make ourselves and the planet whole. For more information, contact us here.